morning all of you. Myself Mamta here and I am from Computer Department GPCG Khuni Majra. The topic which we are going to study today are the Relational Database Management System. These are the topics which are related to RDBMS. The topics that we will go through today are database versus file, DBMS introduction, levels of abstraction, 3 schema architecture, schemas and instances, data models, database languages and their interfaces, the database system environment, and last topic will be centralized and client server architecture. First of all, we'll find out what is the difference between database and file system. In the database approach, a single repository of data is maintained that is defined once and it is accessed several times by various users. The major differences between database and the file are databases are self-describing nature. These are having self-describing feature. They have isolation between the programs and the data. They support the multiple views of the data, and final, they share the data and provide multi-user transaction processing. Next comes the basics of database management system, which is the collection of interrelated data. The data which is of same type, they come under databases. Databases are the set of programs which are used to access that data. Finally, the database management system contains information about a particular enterprise. Maybe it is an object, maybe it is a person, maybe it is a place. The DBMS contain the whole detail about that particular person. DBMS provides an environment which is both convenient and efficient to use. The applications of databases in various fields are as follows. We can use databases in banking for solving all the transactions, in airlines for the purpose of reservations and maintaining the schedules, in the universities for the purpose of registration of the students and dividing the grades of the students, in the field of sales where customers, products and purchase inventories are maintained, in the field of manufacturing for the purpose of production of items, inventory control, placing the orders and supply chain management, in the field of human resources where we maintain the employee records, the salary records, their tax deduction records. Database also touches all the aspects of our real lives. The purpose of database management system includes the drawbacks of using the file system. File system are having atomicity of updates, means the failures may leave the database in an inconsistent state with partial updates carried out. For example, the transfer of funds from one account to another should either complete or not happen at all. Atomicity feature of the database is the most important feature in which the transaction should occur either as a whole or not at all. The concurrent access by multiple users. The concurrent access needed for the performance of the databases, uncontrolled concurrent accesses can lead to inconsistencies. For example, if two people are reading a balance and updating the same balance at the same time, it will lead to the problem of inconsistencies. Next, the file system can also face the security problems because many unauthorized users can access your files and they can provide harm to your files. The database system offers solutions to all the above problems. In the early days, the database applications were built on the top of the file systems. The drawbacks of using file system to store the data were data redundancy and again inconsistency, in which we can have multiple formats of the same file, in which we can find the duplication of the information in the different files, means the same information exists in double form in different files. Difficulty in accessing the data means we need to write a new program to carry out each new task. For each new task, you have to write a new program which provide very difficulty in accessing the data. Next is the problem of data isolation, having multiple files and multiple formats of the files. Integrity problems arises because of the integrity constraints when they become a part of the program code. They are very hard to add new constraints or change the existing one. That is why the problem of integrity constraints arise in the file systems to store the data. Next, we will be studying about the levels of abstraction. The term abstraction means to hide the details from the users. The level of abstraction in databases is divided into three levels. First of all, there is the physical level, which describes how a record is stored. For example, we have a record regarding customer. Every detail of the customer, how they are stored physically, that deals with the physical level. Next is the logical level, in which we describe the data which is stored in the database and the relationship among those data. For example, if we have a type customer is equal to record, we have a record of customer type having the attributes name, street and city, and this is the end of the program. This describes how logically the data is stored in the database and what is the relationship among data. For example, this is the name of the customer, street defines the address of the customer, city defines the name of the city of the customer. Last level is the view level, in which the application programs hide the details of data types. Views can also hide information for security purpose. View level is the external level of the abstraction, in which different users have different views about data and many users can have many different views from the database, and the details of the information can be kept hidden from multiple users for the purpose of security. This is the diagram which is showing the architecture of the database system having three different levels of the database. First one is physical level, which is the lowest level, which describe how the data is stored. This is the logical level, that is the intermediate level of the architecture, which describes what kind of data to be stored, and this is the view level, which is the external level of the database, providing multiple views of the data. Next comes the three schema architecture. The three of the four important characteristics of the database approaches are self-describing nature of the database, which is known as the schema, insulation between the program and the data, and support of multiple views of the data. The three schema architecture was proposed to achieve and to visualize all these three characteristics. DBMS schema at the three levels are defined as internal schema, conceptual schema, and external schema. At the level of internal schema, it is the internal level to describe the physical storage structures and the access path. For example, indexes As in the books, indexes are used to find out which particular topic is placed on which page number. Similarly, internal schemas provide the physical storage structure of the data and the method to access those data. The conceptual schema at the conceptual level is used to describe the structure and the constraints or the conditions for the whole database for a number of users. Means the conceptual schema provide the level of the structure and constraints for the whole database. External schema is at the external level of the architecture, and it is used to describe various user views, means the various views of the users to view the data of the database. This is the diagram you can see. This is the three schema architecture, in which there is internal schema, which is representing the stored databases, mean the data in the databases will be stored in these folders or files. These are a kind of databases storage where the files and the databases will be stored. This is the internal schema at the internal level of the architecture. Next comes the conceptual schema, which represents the conceptual level of architecture, in which the various logics and various concepts and structures of the databases are found. Last is the external schema or the external view level of the architecture, which represents there are multiple external users who can view the database. It comes at the external level. So the mapping between external and conceptual schema is known as external to conceptual mapping, and the mapping between conceptual and internal schema is known as conceptual internal mapping. This is the example. Next comes the definition of instances and schemas, similar to the variables in the programming languages. These are the instances and schemas of the databases which are found equivalent to the variables in the programming language. Like in a variable we can store different kind of values. So variable are the literals who can change their values. Schema is the types logical structure of the database. It is a kind of the logical structure of the database, mean how a database look like, what are the attributes of the database, and what are the number of attributes of the database. For example, the database consists of information about a set of customers and accounts and the relationship between them. This is the definition of a schema. Analogous to the type information of a variable in a program. Like in a program, you use a variable who is having different values at different time in the program. So a variable can store various values or information. These are similar to the schema. A schema can store at a different instant of time different values. The physical schema are those schema in which the database is designed at the physical level. Logical schemas are those schemas in which the design of the databases are done at the logical level. So the description of database is called the database schema, and a displayed schema is called as a schema diagram. Next comes the definition of instance, which is also known as database state, means the actual contents of a database at the particular point of time. Means at a particular moment of time, what are the actual contents in the database, what are the values in the field of the database. These are the instances or the state of the database. This is equivalent to the value of a variable. For example, you can see here is a database of university having tables student, course, section, grade and prerequisite. These are the 5 tables having own attributes. The table student is having attributes name, number, class and marks. So from this example you can see student having attributes name, student number, class and major. These 4 are the attributes of a student. So it represents the overall logical structure of the database. So it is a database schema. Similarly, this is a schema having all the attributes related to course. This is section identifier, course number, semester, year and instructor. These are the attributes which are related to the table or a relation section. And in this example, in this diagram, you can see this is the instance of the table. One possible database state for the company relational database schema. This is the employee relation having at a particular moment of time different values for their attributes. At first time, F name is having the value John. At second time, F name is having the value Franklin. So at a particular moment of time, when your table is having different values for their fields and attributes, it forms the database state or the database schema. Next comes the data models. A model is basically a diagrammatic representation of the data and their relationship. It is a collection of tools for describing data, data relationships, data semantics, data constraints. First and most common, most important model that is used is entity relationship model, which represents the relationships between various entities. Second model is relational model and other models are object oriented models, semi-structured data models and network and hierarchical models. Categories of data models are defined as one fundamental characteristics of database approach is it provides some level of data abstraction. Either it is higher level of abstraction or it is low level of abstraction. When it is a higher level of abstraction, it is known as conceptual data model, which provide the concepts which are very close to many users perceive the data. And the low level of abstraction is the physical level abstraction, which represents the physical data model that provide the concepts which describe the details of how physically the data is stored in computer. The conceptual data models use the concept such as entities, attributes and the relationship between entities and their attributes, where entity can be any real world object or a concept, for example, any employee, a project or a particular student. Attribute represents the properties of that entity which describe the features of the entity. For example, the name of employee is an attribute of the entity employee, or salary represents the attribute of the particular entity employee, and relation represents the relationships or the association among two or more entities in a table. So conceptual data model surrounds only entities, attributes and relationships among those entities and attributes. Here in the diagram you can see this is the entity relationship model, which represents the relationship between various entities. Here we have one entity customer and there is second entity which is account. Depositor is a relation which associates the customer with the account, means a customer can have as many accounts as he wants. Customer is an entity having attributes customer ID, customer name, customer street and customer city. Similarly, account is an entity having attributes account number and balance. So these two entities are associated by relationship which is a depositor relationship. Next comes the entity relationship models which is of real world entities. ER model is always made up of real world entities or the objects which can be customers, accounts, bank branch or any employee, and they also represents the relationships between entities. For example, account A101 is held by customer Johnson. Customer Johnson is having an account 101. Relationship set depositor associates the customer with accounts. As in this diagram, this is a relationship set depositor which will associate customers with account entities. These are widely used for the database design. In these days, entity relationship models are used to describe the overall design of the databases. The database designs in ER model usually are converted into design in the relational model, which is coming next, which is used to store and process the data. So, ER models are converted into relational model. A relational model is represented in a tabular form having rows and columns, in which the rows are having their headings which are known as the attributes of the table. This is a table or this is a relation having name customer, which is having attributes customer ID, customer name, customer street, customer city and account number. These are the attributes of the table or a relation, and each attribute is having different values at a particular moment of time. At a time, the first row is having value for the customer ID 192837465 and the name of the customer is Johnson and street is Alma and customer city is Palo Alto and having account number A101, means the row 1 is having different data for customer details, row 2 is having different data for again customer details, row 3 is having different data for customer details, again row 4 and row 5. Each row keeps a record of customer having different values for different variables or different attributes in the table. When a particular attribute is having a particular set of values for those attributes, this is known as domain of the table or a relation. In a relational model, you can also denote a table as a relation. So, customer ID is having all these 1, 2, 3, 4, 5 values. These are the domain of customer ID. Here, these 5 values are the domain of customer name. These 5 values form the domain of customer street, means at a particular moment of time, an attribute will be having all the values of same type, forms the domain. A single row of the table is known as a tuple or a record. And when we have number of attributes in a table, that forms the degree of a table. Degree of a table means how many number of attributes are there in the table. This is the simple relational database having table customer, account table and depositor table. We are having three tables, namely customer, account and depositor, having their attributes as following, and each attribute is having corresponding values. This is a customer table which keeps record of each and every value related to customer. This is the account table having record of account number and balance. This is the depositor relationship table which represents the record of customer ID and account number. When a relationship associates two tables, it is always having the attributes which are common in both tables. For example, in this depositor table, customer ID is taken from customer table and account number attribute is taken from the attribute of the account table. So, relation, this is the simple example of a relation showing name of the relation, that is student. You can also say this is the name of the table, having the attributes name, SSN number, home phone, address, office phone, age and GPA, etc. These are the attributes of the table and each value of the row is a tuple. This is the table student having 6-7 attributes, 1 2 3 4 5 6 7 attributes and having 1 2 3 4 5 tuples. Each tuple is a row in horizontal direction which is a record of a particular person having values for the attributes. Next comes the DBMS languages, means the languages that we will be using in DBMS. The first step is to create a database through DBMS, is to specify the conceptual and internal schemas for the database. Then we define different languages. The first language is DDL, that is data definition language, which is used by the database designers to define different schemas or the logical structures of the databases. In these languages, we basically use the create command of the language. Data manipulation language is that language with the help of which we can manipulate or update the data in the databases. Next languages are the view definition languages, which are used to specify different views of the user to view the data in the database. In the current DBMS system, the preceding type of languages are usually not considered as distinct languages. DBMS programming language interfaces include the embedding of DML in a programming language. In the database programming languages, the programmer interfaces are used for associating the data manipulation languages in the programming languages. For example, we have the embedded approach of interfaces. For example, embedded SQL, which is used for C, C++, and SQL Java, which is used for Java. Procedural call approach, for example, JDBC, which is used for Java database connectivity in Java. ODBC, which is used for open database connectivity in Oracle, and for other programming languages. Database programming language approach, for example, Oracle has PL SQL feature, a programming language which is based on SQL, that is structured query language. The language incorporates the SQL and its data types as integral components. Next comes the interfaces of the databases, which are very user friendly interfaces which are provided by DBMS, that include the following interfaces. First one is menu based interface, which is used for browsing which represents the user with a list of options which are called as menus that lead the users through the formulation of a request. Forms based interfaces which display a form to each user